Okay, this is the fourth locus lesson, so put your heading, and the title is Locus Theorem 4, which is where we're trying to figure out all the points that are equidistant from two parallel lines. Okay, so all the points that are the same distance from two parallel lines. The locus of points equidistant from two parallel lines, we can call them K1 and K2, is a line parallel to both of them and midway between both of them. Okay? Let's see what that looks like. Okay. Say we have, I'm just going to use my ruler actually to draw both. I'll draw one on the top, one on the bottom. Say we have two lines, two parallel lines. Alright, let's call the first one K1 and we'll call the second one K2. Think of the points that are the same distance from these two lines, right? I can't go above the line because I would be closer to the top line. And I can't go below the line because then I would be closer to the bottom line. So it's somewhere in the middle. Obviously the points that are the same distance from these two lines are the ones that are directly in the middle of the lines. So if I kept making points, right? If I kept making points that were the same distance from both lines, you would get all these points here, right? And if you keep making more and more points, and you do that forever, eventually what happens is you form a line, okay? Because that's what a line is. A line is a bunch of points. It's just a lot of points. You'd form a line directly in the middle of those two parallel lines. So all the points that are equidistant from these two lines lie on this line in between them. Okay? So here's a consider question. During your morning jog, you run down an alley between two buildings which are parallel to one another and are 20 feet apart. Describe your path through the alley so that you are always the same distance from both buildings. Okay? Let's draw two buildings, or at least the sides of two buildings. Okay? I'll say that's one of my buildings, and then I have one that's parallel to it, right, on the other side. So I'm doing the best I can to line this thing up parallel. Okay, so let's say building 1, building 2. Okay. So, you're going to run down an alley. This is the alley, right? Between two buildings, which are parallel to one another, so they're parallel to one another, and they're 20 feet apart. Describe your path through the alley so that you are always the same distance from both buildings. So the distance between these two buildings is 20 feet. Obviously, you're going to be running right in the middle. Okay, that's going to be your path. And you will be how far from each building? You'll be half 20, which is 10. You'll be 10 feet from each building. Okay? It's very simple. It's very basic. Don't make this any more complicated than it is. It wants to know all the points that are equidistant between these two parallel buildings, and it's obviously directly in the middle. That's what this locus theorem says. Turn this over. Write down the answer. To maintain an equal distance from each building, you must jog in a straight line parallel to the buildings and halfway between them. In this problem, since the buildings are 20 feet apart, you will jog on a line 10 feet from each building. Alright, so that is a very nice description of what's going on in that problem. Now let's look at example 1. The locus of points equidistant from two parallel lines. Alright, this is what we're doing. Let's just draw another example of it. These are two parallel lines, the one on top and the one on bottom. The locus of points is a line directly between them, a parallel line directly between them. So one straight line. Okay? Let's go to the next page. This is on your graph paper now. Put your heading. What is the equation of the locus of points equidistant from the lines y equals -2 and y equals 3? So we have to draw an x and y axis. So that's what I'm going to do first. Always label your axes. You'll lose points for not labeling your axis. Okay, y and x. So first the line y equals -2. That goes through the y-axis at 2, and it's a horizontal line. I always make my lines a little bit past the graph, okay, so they can stick out from the x and y axis a little bit. So this is y equals -2. It's got a height of -2. And then we have y equals 3. So 1, 2, 3. It's got a height of 3. So it wants to know the locus of points equidistant from these two lines. Well, I have 1, 2, 3, 4, 5 places between it, so I have to go up 2.5. So I go up 1, I go up 2, and I go up halfway between the next ones. That is going to be my dotted line, my locus. And the equation of that line is y equals 1/2. 0.5 or 1/2. I always put 0.5 because what happens if you don't put that 0 first, a lot of people might not see your decimal because sometimes people draw it really lightly and they'll take points off of that. So I always make sure I put 0.5 rather than just 0.5 so it doesn't look like just a 5. And now I can box off those two. Okay? Very, very simple. No problem here. Let's see. Describe the locus. Leave space at the bottom for that description, but you're going to write that later. Describe the locus of a car that is driven down a straight road equidistant from two opposite parallel curbs on the side of the road. Okay? So, let's draw a picture. I'm going to put a little curb. This is curb. This is curb. Alright. Here's our car. It's going this way. Okay? Equidistant, so if this distance, I don't actually have to measure it, but it's about right there. So the car is going to be driving equidistant from the two curbs. That would be directly in the middle of those two curbs. Just like that. Okay? So the locus of the car will be a straight line. The locus of the car will be, there should be A here. A straight line down the center of the road parallel to each curb. By traveling down the center of the road, the car is the same distance from each curb. Okay? Let's turn this over. Number 4. Describe the locus of the center of the wheel of a train that is moving along a straight level track. Okay? So, there's our track, okay? And I'm going to draw a circle as best I can that's going to represent my wheel. Okay? That's my wheel. And here's the center of my wheel. And the train is going that way. Alright? Describe the locus of the center of the wheel of a train that is moving along a straight level track. Well, as the wheel moves along the track, what happens to the center of the wheel? Nothing happens to the center of the wheel. It stays directly in the center. So they want you to realize that when a wheel turns, the center does not move with respect to the track and with respect to the top of the wheels. Now my wheels don't line up because I drew them different sizes, but they should line up, so I'm going to fudge it like this. Okay, so with respect to a parallel line, which is up at the top of the wheel, and a track at the bottom, the center of the wheel will remain directly in between them. Okay, let's see what a good description of this problem would be. The locus of the center of the train wheels as the train moves along the track will be a straight line parallel to the track. The distance of the line above the track will be equal to the radius of the wheel. Right? The distance above the track is the radius of the wheel. Remember, while the wheels turn, the center of the wheel does not change its distance from the track. So although the wheel is turning, the center is staying exactly in the middle. Okay? And one more problem. What is the equation of the locus of points equidistant from the lines x equals -5 and x equals -1.5 and x equals 1.5? Okay, so I'm going to draw an x and a y axis. Okay. Now, the locus of points equidistant from the lines x equals -1.5, so that goes through 1.5 on the x-axis, and this time it's a vertical line because it's an x equals. Okay, that's x equals -1.5, and then we have x equals 1.5. X equals 1.5. Okay? Well, directly in the middle of those two lines is the y-axis. Right? What's the equation of the y-axis? Well, if this is the line x equals 1.5, a vertical line right here would be x equals 1. A vertical line right here is at x equals 0. That's the equation of the x-axis. X equals 0. It's a vertical line that goes right on the x-axis. Okay? And that is the end of that lesson. We just have to put in the top, on the first page, 1 out of 2, and on the second page, 2 out of 2. Okay? That's the end of lesson 4 on locuses.